Okay, so I do note that there are a few questions in the chat. So from Carl, are concepts being solicited for methods to utilize the arm or primarily instrument science? So from my perspective, and Shaun can jump in here too, we are asking for use cases. So how do you want to use the arm? But our plan is, like Shaun just said, to get the kind of enveloping specs on what we want the arm to be capable of doing, what services does the arm need to provide in order to address the use case that you're identifying. So the first couple slides are talking about the science objectives or I guess the use objectives, we could say, instead of science, if you want to go that route. But and the use cases that are that you're specifying. But then if there are capabilities that the arm needs to provide in order to achieve those objectives, that's the rest of the template, and that is what we're looking for. I guess I should before we go further, the goal of this. So first of all, and you'll get the instructions in the email. We're asking for inputs by the 22nd. So we're not giving you a ton of time, and that part of that is the nature of some of the the requests that we're getting for this information have come pretty rapidly, and so this is a rapid turnaround. So in some respects, we do apologize for that rapid turnaround, but we are hoping to get some input from you on this, and the goal is that Shaun and I will take your inputs and summarize them as kind of an introduction to our next discussion, to give you all an idea of what the community priorities are according to these inputs for the use cases of the arm, and what the spread is of different ideas that people come up with, just as a way to kind of again scope out how the arm will be developed, and or inputs into those designs going forward. So Shaun, I don't know if you wanted to say anything else about prepping for next time before we dive into more questions.
Sure. Yeah, I guess I would like to address the question about general utilization of the mobile robot. The focus of this, since this is the Lunar Surface Science Workshop, it is on science. So if you're thinking about more kind of general maintenance or like exploration, kind of either servicing infrastructure or laying cables and doing stuff like that for building a base, for example, that's outside of the scope of this data call. We're really interested in scientific investigations and instruments for this particular data call. It's not that NASA isn't interested in that stuff in general, it's just not part of this particular data call.
Yeah, thanks, Shaun. It's a really good point. So Pascal has a comment that I'm going to turn over to you, Shaun, as well. But can we describe specific robotic arm and end effector designs and human-machine interfaces to operate them, as opposed to specific instruments to be mounted on the arms?
I'd say, yeah. I mean, if you have an end effector or software, the control software that would be useful for science, that we're interested in that too, along with the actual robots themselves. In particular, if you can show how it could be used as part of a modular interoperable framework.
So Barbara Cohen asks, is this only for instruments that are to be mounted on the arms, or are we asking for instruments whose science are enabled by having an arm? In this case, we are asking specifically for instruments mounted on the arms because we're trying to scope out what the capabilities of the arms need to be. However, part of the concept of operations can include if, for example, you're delivering a sample to an onboard payload. You could include what kinds of samples you need to be collected, right? That's one of the use cases. So that that could involve what you need the arm to do to what types of sample you need to be delivered to an onboard payload. But the specifics that we're asking wouldn't be for, the mass power volume of the instrument that's on the deck. It would be for what the specific capabilities are for acquiring the sample on that end, if that makes sense. Shaun, if you have anything to add to that, please feel free.
I think that makes your explanation is great. Yeah, I guess in terms of, if you have something that you're using for Prism or, clips in general, that data can be useful because it's sort of similarly modular, right? You have the modular interface through the CLIPS lander following their payload user's guide. But we're also interested in the concept of operation as it would be applied to a mobile robot. Right, so that's the very most important part for us. But you certainly can use if you can extract that data to fill out the template, feel free to do so.
And then Avinav Sahu, you asked, robotic arms are used for surgeries on Earth. Can they be used on the moon to address casualties? That is a very interesting conversation to have. It is not in the scope of this particular conversation, but I don't know if Jake is on the line or anybody from the Human Research Program wants to address that potentially in the chat, just to make sure we have time for the other questions that have been asked. But yeah, that's a different application than the science that we're covering in this fall, because the Human Research Program will have their own requirements for arms. All right, let me just make sure. I'm going to go back to the questions for the other speakers in just a moment. So Barbara, you asked also, is the arm you were talking about developing the one that is being offered in the current PRISM call? I would say probably not. It's a different arm. But I would say this isn't necessarily for one specific arm. There may be the potential for multiple arms in development for different uses and for different mobile platforms. So we're just trying to get a sense for what overall capabilities we need robotic arms in general to provide. There are, as you've already heard, there's several different arms that have already been developed or are in a concept phase that this input will greatly influence. And then Shaun, please also.
Yes, yeah, 100%. We definitely are. Like I said, we gave some examples. The speakers today gave some examples, but those are only some examples. The final architecture and certainly the particular robot and even mobile platforms haven't been selected yet. So we're at an early stage where we're trying to develop these enveloping requirements really for what we need the robots to do, and robots combined with rovers or other mobile assets. So that's what we're trying to primarily define with this call.
Fantastic. And then Ernest Bell, you asked if this solicitation for information is for arm uses for deployable instruments as well, and absolutely yes. Again, the idea would be providing information about what would be needed from the arm for the instrument that you want to deploy. You identified seismometers, that's certainly an example. If that instrument requires power and things like that, and data relay and things like that from the arm, then include that. I think we don't necessarily need it for the power. If it's just a standalone instrument providing its own power, then we probably don't need that information, but you can include it if you want for completion. But we really are looking for the resources that the arm needs to provide to the instrument. So for a seismometer, the mass and the center of mass and location point for where the arm would be connecting to it and transporting it, and whether the arm would need to provide any power and data, et cetera, would be important to include.
Right, and yeah, I guess I would just add that we are not considering, we're not constraining it to a particular, like for example, an arm with a fixed end effector only. That we could either have modular end effectors so that, for example, you could use a scoop and then deploy a drill as well, and perhaps also have a general purpose end effector for picking up modular instruments and placing them on the lunar surface. So keep, don't constrain yourself necessarily to thinking that the instruments have to be fixed to the robot arm, although you can, present concepts like that. We're looking for all of those concepts.
All right. So we do have only 5 minutes left on the schedule. There were a couple additional questions that came up for our speakers earlier. Let's see if we can take those last 5 minutes to answer those. I noticed there's another question about when the recording will be available. I'm going to drop that in the chat, the link, and it does take a little time to get up there, but the recording should be available pretty quickly. Just check back at this site. Okay, there you go. Okay, so Ryan, there was a couple extra questions for you. One, are you concerned about regolith entering your motor/gearboxes? If Ryan's there. If not, I do invite the speakers to take a look at the chat and answer the questions if you can.
Sorry, I was double muted. We're accounting for it. We're leveraging a lot what was done at the Mars rovers before for long duration missions, but we'll do additional testing just to make sure they will work for this mission duration.
And one more for you since you're unmuted. What is the maximum payload capacity with the current design?
So we are planning for payloads in the kilogram range.
Great. All right, and then Shaun, if you're still on, there were a couple quick questions for you. And one I think you might have touched on in your talk already, but would there be any advantages to deploying more than one robotic arm on the same rover?
Yeah, there definitely are. Mars 2020 is doing that right now. NASA has the OSAM mission where Maxar is actually flying 3 robotic arms on the same spacecraft. And I could, on my very last slide, I didn't get to it, but I can see situations where you have 2 different arms, like one is a heavy lift. It's more of a precise, dexterous type of arm.
And then one more question for you. How is the sieve configured on sampler? On the sampler scoop, does it vibrate to help sieving?
Yeah, we can vibrate it by vibrating the wrist motor. You can tilt the sieve in multiple different orientations.
Fantastic, thank you. Okay, so with that, I'm gonna draw this to a close. Just keep in mind that we are looking specifically for how, what science objectives and what use cases can be addressed with the robotic arm, and what capabilities the arm has to have to provide resources to the payload. So those are specifically the questions that we're asking for here. When we, and the template will go out via email shortly after this concludes. You will have until September 22nd to provide us input, and then Shaun and I will open our next workshop on the 30th with a summary of those inputs before launching into a more detailed discussion about the capabilities that were provided, and have more focused discussions on each of the use cases is the current plan. More details about that workshop and the format and the agenda will be forthcoming. And Also, do feel free to email Shaun and me as questions come up as you're going through the next few weeks. So thank you all very much for joining us today. It's a great turnout, great interest, and we look forward to seeing your responses as they come in.